That's right. Thanks very much, Ian. Yes, my name is Ruggero Gramatica. I'm the CEO and founder of Yewno is a Silicon Valley-based technology company. And today I will be talking about knowledge graph technology as a powerful data framework for investment strategy. Do I have control of the keyboard, or you guys are going to do that for me? Let me try that. No,
that's page turn for you, Ruggero. So if you just say next slide, we'll move forward for you.
Okay, brilliant. So, okay, we can actually just start flicking through the slides. Next slide, please. Okay, so obviously the market failure we do know very well is too much information, and it's not only too much information, it's too dispersed and too fragmented, and there's a lot of noise, and we heard and my colleagues on this session are talking about how much noise and how much curation data needs to be interpreted. Otherwise, it's just a bunch of stuff that we need to spend too much time to deal with. As we do know, around the year 2005, there was like a clear demarcation from shifting away from the information economy, which has been basically dominating our life for the last 50 to 60 years, where everything was about to produce information, making information available. But with the revamping, if you wish, of AI and machine learning and parallel computing and cloud computing, we enter into the knowledge economy. This knowledge economy is something, of course, more sophisticated, in a way more complex, but actually brings and boosts the information economy and the information into something that would provide much more insights. Next slide, please. So information is fragmented, we said that, and information is not the same as knowledge. There are plenty of literature and statement about that the way how information is generated every day is really unbearable, and it would take over 3 trillion years for a team of 10,000 analysts to read and process and digest unstructured information. So basically, the information economy is not scalable. Next slide, please. What is a graph solution? What is a knowledge graph? A knowledge graph is a new data framework. We know that a knowledge graph is becoming kind of a buzzword in the last few years. In the knowledge graph, there's a bit of a confusion because at the beginning, people thought a knowledge graph was mainly a way to visualize in a kind of graph way structured data or information that has been already structured. Well, a real knowledge graph is something that deals mainly with unstructured information, and most importantly, a knowledge graph must maintain a dynamic behavior, meaning that information keep on coming through, and there's so much information, and this knowledge graph that is formed, or as we say, that the knowledge graph that is induced, is like a gigantic ball that keeps on rolling, and you need to basically deal with the dynamic component, the dynamic element of a knowledge graph. So a knowledge graph is something that can connect the world of information, even across domains, not within the same domain, that can derive the knowledge from the information that has been processed, and obviously can support decision-making at speed and scale. Next slide, please. A very trivial example, something that we all know very well, but just rewind your memory to when, for the first time, Bitcoin and cryptocurrency happened. A knowledge graph would be able to capture a very interesting connection of a concept that extracts information, a concept like Bitcoin that is connected somehow to another concept like cryptocurrency, and then again GPUs, and then again NVIDIA. And every time that there is a connection, you also find the correlation function, so why any two pair or any two nodes are connected. So this is actually seems trivial today because we know very well what actually entails behind Bitcoin and cryptocurrency. But again, if you just happened at that very moment a few years ago, a knowledge graph will be able to capture this in a much quicker way. But most importantly, next slide, what a knowledge graph does is, next slide, please. Perfect. what a knowledge graph does is capture the inferred connection. So something that is not necessarily being written or tracked anywhere, basically it kind of connect point of the graph that carry a certain behavior because of other nodes. In this case, Bitcoin is inferentially connected to NVIDIA because of a path. And that's very powerful because it allows us to not only extract path and first order connections, second order connections, and third order connections, but it allows us to derive some sort of inferred knowledge and inferred intelligence. Next slide, please. Knowledge graphs that we typically use are based on keywords. The more powerful knowledge graph are those based on concept. And a concept could be one word, two words, it could be even an entire sentence. A concept is something that could be a material thing, could be like a jaguar and helps with the disambiguation. Am I talking about Jaguar the cat or Jaguar the car, Apollo the private equity firm, or Apollo the rocket ship? But it also allows me to identify concepts that are abstract, and that basically comes and appears all of a sudden, like Brexit, or coronavirus, or a trade war, or interest rate, or people like Donald Trump, Elon Musk. So there are many more concepts than words, and it's quite important to have a system that is able to dynamically digest and read information, extract concept, correlate the concept, and we will see in a minute how to. Next slide, please. So a concept is projected into a multidimensional space. And what we do, we utilize certain type of embedding methodology, which basically you create a vector whose direction, intensity, and modules is quite unique and does represent uniquely a concept. So in this example, you may have the concept Jaguar and the concept Jaguar the cat and Jaguar the car, because of their context, will be projected as two different vectors into a different space of the domain in which they are projecting. So if you iterate this methodology, and you keep on reading and reading and reading, and you keep on identifying new concepts, and bundles of vectors are created and projected into a semantic space. At that point, correlations start forming one another, and correlation could be of many ways. Could be statistical correlations, could be syntactical, ontological. It could be just as a pure emerging property of the graph itself. Next slide. The good news is that this methodology is also it comes naturally language agnostic, and it can read words, it can read numbers, it can read images, but basically it is about reading, and project all this information with their correlations into space. And at that point, we have the new data framework that is very dense and rich of information that has been processed and correlated, and most importantly, it is dynamic. Next slide. The dynamic element is very important, and the metaphor that I use all the time is like when a few years ago or a couple of decades ago, we used to watch a movie on a physical film, not digitized. So ideally, you could unroll a film and be patient enough to watch it frame by frame over time, and you can devise the story of the movie or devise the story of the team. You can even focus on a specific area of each individual frame and observe what happened to that specific area over time. Well, the metaphor holds also with knowledge graph. Having a dynamic knowledge graph that actually keeps on evolving because information keep on coming through, and being able to keep pictures of a knowledge graph every 5 minutes, every hour, every day, every month, depending on the frequency of the data, and you have a very large data content, you do have this information that comes at a different and disparate time of the day or of the week. Then you can really go back in time years, 5 years, 10 years, 20 years, and then observe and trying to unfold the graph over time. and observe and extract the signals that are typically knowledge extraction of the specific query you are interested in. Next slide. The data framework, for instance, that we used is very, very large. So the content, we have ingested about 500 million content ingested. We do not scrape the internet per se, but we do actually focus in hunting. That is the only manual curation that we spend a lot of energy and resources in creating ingestion pipelines to normalize the data, and eventually the algorithmic part does its work by extracting the knowledge and correlating the knowledge, correlating the concept into knowledge graphs. And I say knowledge graphs because at the end of the day, it's not one unique graph, but there are many graphs that, like in the picture you can see on the left-hand side, they look like more a multi-story building. Each graph represents a specific domain of correlated information, and you have several domains. It's like a multi-story building. You have staircase, you have elevators. You can connect also this sort of knowledge. In the overall financial applications, of course, we have plenty of data that comes from the financial services, from news, patents, official filings, transcript, clinical trials, judicial document, scientific publications, stock prices, and many, 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 many more. On the right-hand side, you have just at a glance the type of data that we ingest. And next slide, please.
Sure, right. Just before you move on, a question which I thought you might want to answer as you go. So a question from Ashok, which is saying, asking about the edges in the graph. So he's raising the question that the edges in the graph could have a different meaning. So it could be part of, supplier of, produces. And Ashok's wondering, would you have different knowledge graphs for different kind of characters of relationships, I guess, is a way of summarizing the question?
That is a great question, and the short answer is yes, but it's not. We are not identifying different graphs, but and that's why, at the beginning I said this is a multidimensional type of knowledge graph, meaning that every connection between any two nodes, it is indeed an array of relationships. So Ashok's question is properly right, and he mentioned specifically ontological type of relationship. So we do have one of the dimension of correlations of edges within the graph are ontological based, but then we also have syntactic correlation, something that we have a quite an evoluted system that extracted the syntactic subject, verb, and predicate, and track potential semantic inference. We have statistical correlation, something that emerged because of the nature of the graph and the statistical and mathematical property of the graph itself. And then we have also other algorithmic type of relationship, but not only between nodes, but also between or across clusters, and cluster to cluster, cluster to nodes, and so on and so forth. So there are quite a large combination and permutation of type of relationships. Ontological is one of those. Thank you. So on the next slide, the induction of a knowledge graph, therefore, is summarized in this slide. We read a lot, we extract the concept, we do identify the correlations in the many forms that we just said, and we induce the graph eventually. And this is a very messy cloud of correlated information, as we said, but it's very powerful. And because we keep a history of tens of years back, and the frequency is quite important, then we're able to unfold the graph. And there's plenty of ways how you can unfold the graph and try to extract signal over time. And on the next slide, we can see basically how you can do this. Now, very important, this is a slide that we will see in the next few slides before the end of my intervention here. That is about, everything is about exposure. Exposure is a definition that is quite intuitive, but exposure in a graph is something even more powerful, because it tells you how any single concept or cluster of concepts can expose themselves quantitatively into some other concept They could be neighbor, or could be far away within the graph, or it could be even across graphs. And that is quite important because it is at the basis of the investment strategies and other products that we offer through a knowledge graph. Next slide, please. So the next slide again. So the offering broadly, just a subset. What do we do with a knowledge graph? What do you do with this very complex data framework, but yet powerful? And what do you do with an engine underneath that calculates the inferences based on exposures? This is just some of the product that we offer and we are able to produce, which is basically alternative data and APIs. Obviously, a knowledge graph that is large enough and incorporates a different type of data is a natural repository for extracting alternative data. We build in the strategies and ETFs, and we built a investment research platform that is able to, in a kind of more interactive way, to inquire the graph and extract information for building strategies. So next slide. Data feed, alternative data, as we discussed, is about hunting for exposures. Could be systemic exposure, country exposure, geographic exposure, revenue exposures, or any type of relationship exposure, which basically is at the basis of the build-up of correlations. Next slide. This type of alternative data span from smart beta. It could be sentiment-based. It could be prone to extract alpha signals, or it could be just purely to build risk modeling or multi-factor model for risk assessment. Next slide. This is just an example. We have alternative data extracted from the graph based on patent analytics, based on judicial. I believe we have ingested US court opinion since the late 1800s. And we're basically, and we keep on updating this, we're able to build a multi-factor model that provides information on how risky is your portfolio based on probability of a given company to be sued for patent infringement, discrimination, sexual harassment, and so on and so forth, or ESG exposure or type of strategy. And ESG is a typical theme or thematic type of exposures. Next slide. We can see a few, actually 3 use cases just to kind of fix the overall purpose of what we said so far. So let's see how an idea generation thematic strategy can be constructed through a knowledge graph. So next slide. We have basically built a number of indices, thematic indices and ETFs, and with this partners that we launched through stocks and Nasdaq Selective, just to name a few. And the reason why a knowledge graph is a great instrument for building an ETF or an index is because the immediate way how you can build up correlation or exposures and extract the constituents basket and validate it and backtest it. And we can see this on the next slide as an example. For instance, we have a series of tasks that you go from the methodology design out of knowledge graph, in this case out of 5 million concept. There is the construction of the type of factors that you want to investigate, polarity measures in this case, that you can really give a sense, a color to the type of correlations. Unfortunately, this slide does not show, for some reason, there were some other graphics next to the arrows, but basically the graphic was saying what I'm saying now. So there are like 3 phases, and eventually you extract and project the index with a backtesting. The whole methodology is done by the knowledge graph, apart the initial phase when we design the way how, what kind of framework we want to identify. And it typically takes no more than 3 weeks to have an index ready to be already backtested and ready to be calculated and validated.
Ruggero, just another audience question. I think it's great to do them as we go along because it's at the right time. So
Sure.
Rohan is asking how your indices distinguish between positive and negative exposure to a concept. So he gives AI as an example where I guess one could be either a beneficiary or perhaps threatened by AI.
That's right. That's a great question. Polarities measure are typically based on sentiment, right? So sentiment is an algorithm that has been trained by reading millions of documents and gone through a semi-supervised phase where basically humans have labeled what is positive, what is negative. At that point, it is a machine learning algorithm, and we trust the accuracy of the machine learning algorithm to define whether it's a positive or negative. Obviously, and Rohan, I think actually could be the next question for Rohan, it's obvious that some of the concept can be positive on one perspective or negative from another angle, right? And that is very much boils down to when you combine a multi-factor, so you can actually skew when you have a positive or negative conflicting one another to one way or the other.
Well, I'll keep an eye out for that one. We're running slightly over time, Ruggero. So perhaps if we could aim for another 3 or 4 minutes, that would be great.
Okay, I'll go actually quickly just go that through quickly. You can actually then go ahead of the next slide. Well, actually, the graph is coming.
The animation. Yes, that's why.
That's why. But that was the dynamics that actually everything happens in 2-3 weeks upon the design phase. Next slide, please. You can build a strategy specifically on, because we said that the knowledge graph is based on concept, by just entering, that is just one of the user interfaces, for instance, coronavirus, telecommuting, telemedicine, you enter this, what are you doing here? You're inquiring knowledge graph saying, can you build for me a constituent basket of companies that are exposed, that is a multi-factor model, on the knowledge graph with those 3 concepts. Next slide, and you can backtest it right away, right? You can, under your eyes, and you can compare it to a benchmark, and then you can tweak the factors that you have defined the slide before. Next slide again, and that will be very quickly now until the rest of the presentation. Or another example is a vaccine factor strategy. You enter basically the concept of vaccine, and then you build many companies out there, you see their exposures, and again, next slide, you eventually see the backtesting, and you decide the type of backtesting and weighted schema that you want to have, and then you have an idea whether your basket is, or strategy is viable or not. And you can add other concepts as we've seen before. Next slide, please. You can use it on risk management. Next slide. And in this case, you want to understand whether your Microsoft type of investment, what are the main other company exposed to Microsoft that you might not realize. And you can see basically exposure extracted in this case. So they are suggesting that to you instead of you kind of entering. You have a long-term exposure or short-term exposure, that because of the dynamic of the graph. And the next slide shows you, for instance, in this case, TikTok exposed to Microsoft. You can see at some point there is the exposure value that immediately spiked up. You can compare it to the price, the market, the stock price. You can basically draw your conclusion on the sentiment analysis that is plotted on the bottom of the screen. Next slide again, we're almost done. Last case. Last case is basically a combination of what we saw before. Next slide again, sorry. You can actually use this as a document search. You enter again concept, you enter again type of ideas, you can retrieve. Don't forget the knowledge graph is being built by reading hundreds of millions, actually billions of documents. You can retrieve the specific document and actually have your explanatory or your narrative behind of what you're looking for. Next slide, please, with all sentiment and other things. And I believe, next slide again, we are almost, yeah, we're done.
Wonderful. Well, Ruggero, we did questions as we went along, but thank you so much for that. And as I mentioned on the previous presentation, we do believe it's a real signal what buyers are interested in. And Yewno at actually our last couple of physical events has been in the top 3 or 4 vendors in terms of demand from the buy side. So Ruggero has a couple of slots left in the one-on-ones, not many. So for anyone who hasn't participated, please do. You're about to hopefully receive a reminder of how to participate in that if you haven't already. But certainly, again, a business that we've seen develop out of academic work and moving into a WeWork, and now a very significant player in our little world of alternative data. So encourage you either through ourselves, through the one-on-ones, or directly to Ruggero to reach out. Thank you very much, everyone, for today, and thanks, Ruggero, for presenting there. Just a little reminder of what we have tomorrow. Well,